The invention of the analytical ultracentrifuge has changed the way scientists have approached the fields of molecular biology and biochemistry immeasurably. The analytical ultracentrifuge allows scientists to observe molecules in solution and has assisted in the study of DNA, proteins, carbohydrates, and polymers, among many other items. This timeline outlines some of the major advancements in analytical ultracentrifugation, providing a historical snapshot of the device and its importance in the fields of science, medicine, and industry.
News on the March. The history of the AUC, that's Analytical Ultracentrifuge. The 1920s.
The Roaring Twenties were a time of great prosperity. As the flappers broke gender barriers and talkies changed the way movies were made, Theodore Svedberg was breaking new ground in the way we study molecules. Svedberg invented the analytical ultracentrifuge in 1925 to assist his research on colloids and proteins. For his invention and work on dispersed systems, Svedberg was awarded the Nobel Prize for Chemistry in 1926. In addition, the 1920s also brought us the Lamb equation, which describes the sedimentation and diffusion of a solute under centrifugal force. The equation was derived by Svedberg's protege, Ole Lamb. In addition, tertiary and quaternary structures were also established, which showed that proteins were of a clear shape and structure. As the old adage goes, structure defines function, a concept still relevant today, shaping our understanding of many biological processes.
The 1940s?
In the decade that saw the first computer being built, the Spinco Model E became the first commercially available centrifuge in 1947. The Model E allowed scientists the ability to make such breakthroughs as developing plasma and blood volume extender methods for transfusions, determining size, shape, density, and electric charge of molecules, and establishing the basis of protein science and molecular biology.
The 1950s.
While families were seeing beautiful color in their home television set for the first time, scientists Meselson and Stahl were conducting the most beautiful experiment in biology, discovering the semi-conservative replication of DNA. And while people joined and separated Legos and Velcro in the 1950s, scientists were making one of the most significant scientific discoveries of the century: the building blocks of life. The discovery of DNA changed science forever. In the lab, the Johnston-Ogston effect helped to understand the sedimentation of two component systems.
The 1960s.
In the 1960s, while Star Trek hypothesized the future of science, the present saw the development of Rayleigh interference optics in Schachmann's laboratory, giving us the ability to characterize particles outside of the visible UV spectrum. This gave us the ability to analyze particles we can't see.
The 1970s.
In the 1970s, the release of the pocket calculator helped us attain more accurate math calculations. The development of flotation sedimentation techniques opened up capabilities to study low-density molecules such as detergents and lipoproteins.
The 1990s.
While the internet changed our lives forever in the 1990s, so too did Beckman change the scientific landscape with the release of the Optima XLA and XLI analytical ultracentrifuges. Most notably, their capabilities of electronic data collection and analysis through popular software packages such as SetFit, Ultrascan, and DCGT+ allowed scientists to quantify data with greater precision and more accurate results.
2000s and beyond.
The advances brought about by analytical ultracentrifugation can inspire us to anticipate the scientific breakthroughs of the future. AUC technology allows a greater focus on speeding up scientific advances and having a greater societal impact. The technology is expanding into the biopharmaceutical market for drug candidate selection, biosimilars, aggregation analysis, and formulation studies, and discoveries in the fields of nanoparticles, proteins, biologics, and many other breakthroughs will change the scientific landscape for decades to come. At Beckman Coulter, we are excited for the future.